Okay, so it's 10%. 10% of an unknown, yep, equals $54. Yep. Okay. So like every question, what we do is we try and work out what it is we know and what it is we don't know. All right, and from that, if we take this down, what do you know about a number followed by a percent sign? Pardon? Times 100? It's the number divided by 100. Yeah, okay, so anytime you see a number with a percent sign following, it is the number over 100. Okay, what does of mean? To times. We don't know what this is. It's just an unknown. We just called it x. Doesn't matter, we just don't know what it is. All of that equals $54. Okay. Now, we have known in the past that in order to get x on its own, we have to get rid of this, don't we? We have to get rid of this here. Okay? If we brought that down, how could we simplify that? Pardon? We could. Could we make it as a decimal? Good girl. 0.1. 0.1 times by x equals 54. Straight never works on the full. How do we get rid of 0.1? How do we make it 1? Anything divided by itself is 1. So what could we do to 0.1? No. We could divide it by 0.1. If we were to divide that by 0.1, you do that on your calculator, what do you find is the solution? 1. That's what we're trying to achieve, isn't it? We're trying to make this here the number 1, because 1 multiplied by anything is whatever the anything is, yeah? So we've made that 1. What haven't we done yet that we must do? If we've done this on the left-hand side, what do we have to do on this side? Do the same. Good. So 1 times x will equal 54 if we've divided by 0.1 on this side of the equal sign, then we must divide everything on that side by 0.1. Okay? When we do that, 54 divided by 0.1 is 540. Okay? X equals $540. Because 1 times $540 is 540, yeah? So x equals 540. We can check that. We can check that. We can say we predict that x is 540. What should 10% of 540 equal? What should 10% of 540 equal? It should equal $54. Shouldn't it? We can check it. 10 divided by 100 multiplied by 540 should equal $54. And if it does, then x is $540. So there's a way of checking your answer to see that you've actually got it right. Okay? You understood that? You understood that, Michaela? Can I explain it better for you? No? Righto. Okay, green and blue, I just want you to put your pens out of your hands for a minute, please. I just want to talk to you about the area that you should be working in, which is your percentage increase and decrease, which is page 37. Some are beyond it, some are coming to it, some are nowhere near it, some are well past it. Okay, those that are well past the multipliers, which is percentage decrease and increase, you make the judgment of whether you need to listen to this. Okay, so you make the judgment on whether you need to listen to this. But if you're in the green group, you're all listening to it. If you're in the blue group, you're well past it, then you don't need to. So they don't specifically call them multipliers in here, I don't think. But that's the way I'd like you to refer to it, because that's the way we refer to it in senior maths. Okay, and all of you are at least doing year 11, and I know multipliers are involved in year 11 maths. Okay, so multipliers is talking about increasing an amount by a percentage or decreasing an amount by a percentage. Okay, so let's take a question which says increase $5 by 30%. Okay, we're increasing $5 by 30%. There's two ways we can do this. Like in maths, there's probably 3 or 4 or 5, but I'm going to show you 2 ways we could do it. Okay, the first way we could do it is to say, well, you tell me, what's one way we could do it without using multipliers or percentage decrease increase at the moment? What's one way we could do it, Jaden? Work out how much 30% of $5 is. Good. How would we go about that, Jess? Okay, so what are we trying to find? You're saying you're not sure. What are we trying to find? 30. Did I hear you say 30% of $5? That's what we're trying to find, isn't it? We're trying to find 30% of $5. Yeah? Okay. We should be able to go from here, shouldn't we? 30 over 100 times by $5. What does that give us, please, Jess? So really it's 0.3 times by $5. Yeah? What is it? 1.50? Yep. $1.50? Yeah, 1.50. We're increasing $5, so we're increasing it, so we're adding that $1.50 we found. So we're going to end up with, if we increased $5 by 30%, we'll end up with $6.50. Okay? That's probably the long way and the long process that you would have done it before. Okay? And I'm going to talk to you about multipliers in terms of how we could do it quicker instead of having to do this section here where we're adding it to our original amount. Okay? When we're increasing $5 by 30%, we're going to have the 100% of $5, aren't we? We're going to have the $5. That there is 100% of $5, isn't it? Plus this is our 30%, isn't it? We're going to have 100% plus our 30%. So really what we're trying to find is 100% plus 30% of $5. We're trying to find 130% of $5. Are you okay with that? We're trying to find 130%. Now, just as I spoke to Jess and Michaela before, anytime you have, and I spoke about it the other day, anytime you have a number followed by a percent sign, you should say to yourself, it is the number divided by 100. That's what you should be saying to yourself. It's the number divided by 100. Anytime you see a number with a percent sign following it. So this will look like this. Yeah? Okay. What does of mean, Cheyenne? Good stuff. $5. Okay, what's 130 over 100, Jared, as a decimal? 130 over 100. You can use your calculator or you can go 1.3. You can use your calculator, or you can say we've got 2 zeros on the bottom, so we're moving our decimal place 2 places to be 1.3 times by 5. You might not even put this line in. I'm just trying to do the line of your thinking, what your thinking should be. So everybody on your calculator, please, so you know how to do this. I want 100 multiplied by 5, or 1.3 times 5. And you end up just with 6.5, which is $6.50. See how by using a multiplier we get straight to the answer? Our calculator spits the answer straight out at us. We don't have to do this, this extra one in here. Alright? So we're finding 100% of it because we're increasing. We're finding 100% plus the next 30%. Can I explain that better? Maybe if we look at example 19 on page 37. Example 19 on page 37. Increase $70 by 15%. Increase. Okay. The moment we're increasing, you'll notice that we're doing 100% plus another 15%. That 115% is 115 divided by 100, which is 1.15. Okay. And then we're doing $70 times 1.15 gives us $80.50. Whatever our calculator spits out to us, we're in a question which says increase something by it. Whatever our calculator spits out, because we're increasing, the answer should be larger than our original amount, shouldn't it? That's what we should be thinking. Okay. This will be a challenge to get this. So now I want us to look at decreasing an amount. Okay. Let's decrease, use the same amount, decrease $5 by 30%. So decrease $5 by 30%. What are we thinking we have to do here? It's not going to be 1 point something, is it? Because we're reducing it by 30%. So how much of your $5 will you have? Think about that question. How much of your $5 will you have at the end of this if you're decreasing it by 30%? How much of your $5? Not the answer. I'm not asking for the answer. What percentage of your $5 would you have if you're decreasing by 30%? You'd have 70% of it left. And what did you do there? You did a calculation in your head which said, no longer have I got 100% of it. I've got 30% less than 100%. Yeah? But 30% less because I am decreasing. Okay? So what I end up with is and you can probably do that bit in your head when you get to it. You've got 70% of $5. 70% of $5. 70%, Beck, 70%, what is that as a fraction? Remember, any number followed by a percentage. 70 over 100. Good. 70 over 100. Of course, means to multiply $5. That's sort of 0.7, isn't it? This is your thinking. 0.7 times 5. Do that on your calculator. Ellen, just to keep you awake. I see you yawning there. I'm sorry to bore you. 3.5. You have $3.50 remaining if you decrease $5 by 30%. Okay? So if you're... Got everyone going now, Ellen? This is going to be recorded too. You've got... When you're increasing something, okay, it's 1 point something. Okay? When you're decreasing something, it's less than 1. Because you haven't got the whole of it, you've got 0.7 of it. On this occasion, it's 100%. Take whatever the percentage is. All right? Any questions on that? Jared?
When you go from 70% to 70%,
I'm quite comfortable, Jared, if you just go there and then there.